everyone, I'm Raya Pakulana. Welcome to this video where we'll be discussing something really interesting, a stereographic projection. If you've ever wondered how we can map a 3D object like a globe onto a 2D surface, like a piece of paper, this video is for you. Okay, so what is stereographic projection? Here's the illustration showing the stereographic projection concept. Stereographic projection is a method of projecting points from a sphere onto a plane. This is a common way to represent the Earth in 2D maps. What makes it special is that it preserves angles, meaning shapes like countries will look correct even though the size might be distorted. But how does it work? Imagine you have a transparent globe. You place a flat piece of paper right under the South Pole and then draw a straight lines from the North Pole through the surface of the globe until they hit the paper. This creates a 2D representation of the points on the sphere. Next, the key properties of stereographic projection. Now let's break down some important properties of stereographic projection. The first one, angle preservation. It is one of the coolest things about stereographic projection is that it preserves angles between lines. That is why it's often used in mapping to accurately show directions and shapes, even though the sizes might be distorted. The second one is circles remain circles. If you draw a circle on the sphere, it will also appear as a circle in the projection. This is really useful in fields like cartography, where preserving shapes is important. The third one is distortion. While angles are preserved, sizes are not. The farther away a point is from the center of the projection, the more it will be stretched or distorted. So, regions near the edges of the map, like the poles, will appear much larger than they actually are. So let's try to visualize how stereographic projection works. If you have a ball, imagine that every point on it is being projected onto a flat surface below. The lines connecting the points on the ball to the plane all come from a single point, in this case, the North Pole. It's almost like the shadow of the ball is being cast onto the paper. An illustration showing how stereographic projection works with the ball and flat surface demonstration. It visually represents how the points from the ball are projected into the plane. So let's look at another illustration that makes stereographic projection easier to understand. So in this illustration, we're looking at how stereographic projection works. Imagine a sphere in 3D space. We call the top point of the sphere the North Pole. Below the sphere, we have the complex plane, where every point represents a complex number. To map a point from the complex plane onto the sphere, first, we start by picking a point on the complex plane like z equals 1 plus I. Then second, we draw a straight line from the North Pole through the point z on the complex plane. This line hits the sphere at the point which we call z. That's the projection on z on the sphere. So if z is close to 0, z will be on the lower half of the sphere. If z is far from 0, z will be closer to the North Pole. For very large numbers, z will approach the North Pole. In our example, z equals 1 plus I gets mapped to z equals 2/3, and 1/3 on the sphere. These methods helped us visualize complex numbers on a 3D sphere. So, this illustration, it might be easier to understand and shorter while still explaining the key ideas of stereographic projection. So, that would be all, and thank you for watching.